Hey guys, me and Natalie here. This is my little girl Natalie. Do you want to say hello?
Hello.
Hi. We're just in our basement. I'm home alone with her right now, so she's going to help me film this video. We're going to just answer a few questions and just give demos on the right hand rules. Okay? Do you know which one's your right hand? You want to show them your hand? Your hand. She knows what her hand is. Yeah, very good. That's your left hand. Okay, so we've got this really cool setup. Natalie helped me get ready here. I'll just put this down so you can see what I want you to see. There we go, that looks pretty good. All right, so what we've got here, what we've got you seeing is we've got a magnetic field. B is coming from these two magnets. That's where magnetic fields come from usually, but they also come from wires, right? Wires with a current going through them. That's what we've learned. And so what happens when we put a wire in between two magnets? So I don't have real magnets here at home. I've got this. So we could say that this little magnet is just sitting here like that, right? Magnetic fields are created by magnets. So we got a wire with a magnetic field around it because there's electrons flowing through it. So let's just say that the current in the wire is going that way. Okay, so that's I. One thing I want to highlight that might come up, I is that way. That means that protons would go that way, right? Protons would go that way, which means which way does the real electricity go? Electricity is the flow of electrons. Electrons would flow the opposite way. So if you ever get a question where it's telling you electrons are going to the east, you know the current, I, is going to the west, okay? So let's just be clear on that. So you've got this wire is going that way, okay, or the current is going that way, and the magnetic field is that way. So let's say that this is going west, while the magnetic field is to the north, right? Let's not get that confused with the north side. It's going towards the north, which means which way would the wire feel a force if this was the case? Here's where we use the right-hand rule, number 3, okay? It's a straight wire through a magnetic field. Your thumb is the current. So your thumb goes that way, and your fingers are the magnetic field. Fingers going north. Thumb, fingers, put your hand down. And what are you left with? Where is your palm facing? My palm is that. Oh, that's big on this screen. I should have given you more room. I'll try on the next one. Okay, your thumb down, fingers up. Your palm is left facing into the page. So you can see that, right? My thumb is that way, fingers are up. My palm is into the page. And so the force is into the page. That big circle with an X around it, okay? That's the force. How do we know that? It's because of where our palm faced. We put our hand and our palm faces down. Okay, so another type of question that you might get would be something like this. A little further away now. This is better. The magnetic field is represented by black here. So if the magnetic field is, what direction is this? All these little circles are all out of the page. So if you see something like this is just saying that everywhere between here is out of the page, which means there's this large magnet down there that's directed out of the page, okay? So that would be a big north pole magnet, right? And the force is down or south or something like that, okay? And they're going to ask you the question, or I will actually ask you the question, what direction is the current? I is, where? I would use a different color. I only have 2 colors of markers at my house, so that's how it goes. We've got force down, magnetic field up. So we use our right hand, okay? The one that doesn't make an L. And what do? Well, we put our force down. That's our palm. Remember, you hit with your palm. So how do you line up your palm to be down? It's like this. So as you can see, my palm is down. Okay, my palm is facing down, not into, this is like down as in south. Okay, and now my fingers are the magnetic field and they have to be out of the page. So this is messed up. Why did I do this example? This gotta be this. This is terrible. Do you guys know what I'm doing? Can you see this? It'll go on the other side of this thing. It's gotta be like this. You gotta be creative sometimes to even get your hand into that position. So if you can see what position my hand's in, my fingers are up, out of the page, into the screen, out of the page, and my palm is facing down. There, thanks, Natalie. And my thumb is left going to the west, okay, or to the left. And so, what's lots of fun is in class, which we don't get to do, seeing people just putting their hands in weird positions, okay? And it's lots of fun to do that, but that's how it is. There it is, okay? Oops, like this. There it is. We got our force, our palm is facing south, our thumb ends up facing, that's east. Did I say west? It's east. I was on the other side, and our fingers are up. That's how it's got to be, all right? Okay, one more example. I'll try to do this one quickly. We've got the force going into the page, and we've got the current going up. Okay, so that'd be as if we got a wire where the current is up, which means electrons are flowing down. Don't let that mix you up. And the force into the page, that way, okay? So it's one more example. Palm needs to be into the page like this, which means my hand could be, the current could be anywhere on this plane. But as long as my palm is down, but the current is up. And so very quickly we see, once we get quick at this, we see that the magnetic field must be that way. And so we're left with this being the magnetic field. And that's all it takes once you get used to this. Always be looking for two directions, and then you just got to line it up properly, okay? So you do like that. All right, that's it for today. Thanks so much for joining me. It's good to see you. Welcome to my home. And I hope that this made some sense and helped clarify some things. Okay, see you guys later.